Good morning, everyone. Today, inshallah, we will go through our third chapter. Our third chapter will be about determinants. It's very, very simple topic, and it's connected also to what we did go through in the previous lectures. Of course, you will find everything on Moodle. I've also sent you the last update of the slides on the WhatsApp, just in case if you want to go through them. I will go through them with you. But as I told you before we start the recording, I will go with the determinants with a couple of my slides. Then I will go in details, okay? The topic is really very simple. What's a determinant? A determinant, it's a value relative to a matrix. So each matrix should have certain number, what we call it a determinant. We can succeed in evaluating determinants really very easily. There is a lot of ways in order to evaluate a determinant for a matrix. The value of the determinant can be determined. Follow the coming examples. I thought this is going to be the easiest and the most practical way in order to evaluate a value of a determinant. So, for a matrix, we already know about matrices. We know that we can form a matrix from a system of equations by getting the values of the coefficient matrix, for example, which are the coefficients in front of all the equations that you want to solve. So if I have a matrix, let's say A, and the A matrix is a 2 by 2 matrix, a square matrix, which is simply can be any numbers like those. For example, if I will put any numbers, let's say 5, 6, 2, and 0, for example. This is a matrix called, it's a 2 by 2 matrix. So if it was representing a system of equations, you are dealing with two equations and two unknowns. This is why you have four values. If I want to get the determinant, a determinant for a matrix can be symbolized by these two lines. It's like the absolute or the magnitude, but they are not relative to this. It's just the meaning of it. Some of the main books also, or the textbook, use this symbol for determinants. So it's a determinant relative to a matrix, and it is simply going to be, you will have to change the square brackets or the parentheses of the matrix to be the those types of parentheses. Then I will have 5, 2, 6, and 0. The main idea is to multiply the elements of the principal diagonal in each other. Then I will take the net minus the secondary diagonal. So if I want to evaluate this determinant, it's going to be very, very easy. All I have to do is to get 5 times 0, then I will put a negative sign, 2 times 6. So the result will be, evaluate the value, so it's going to be 0 minus 12, so the result will be negative 12 for this determinant, which is a real number relative to a matrix. That's the determinant. We will need the value of the determinant down the road in order to choose what's the successful method, one of the successful methods that I can use to solve a system of equations, as you will see. Okay, if I have this determinant, it's really very simple. All you have to do is exactly the same. I will get the multiplication of the elements of the principal diagonal or the main diagonal, which is going to be 10, then minus sign, 1 times 4, so the result will be 6. It's really very simple. If I have a matrix 1 by 1, square matrix, 1 by 1, 1 by 1, it means 1 row and 1 column. So if I have a matrix, let's say A 1 by 1, which is simply 6, for example, so this is going to lead to that the A determinant of this relative to this matrix is going to equal to 6. Okay? Okay. What if I want to go for a matrix which is 3 by 3? 3 by 3, we will have to know some of the probabilities, a little bit about the probabilities of the determinants, and I will give you two main methods to be able to evaluate the value of a determinant for a 3 by 3 determinant. The first of them, I believe we did go through it previously, which is the cofactor method. So if I have, for example, a matrix A, which is simply 3, 2, 1, 0, negative 1, 3, 4, 5, and 6. Any numbers, any set of numbers. That's a square matrix, which is 3 by 3. Before evaluating the corresponding determinant for this matrix, we should know what's called the sign rule of the cofactors of this matrix. The sign rule states that for any matrix, you should start by positive, negative, then positive. If I have 3 by 3, I will write them in a zigzag manner. So I will start positive, negative, positive, then negative, positive, negative, then positive, negative, positive. Remark, I'm walking in a zigzag manner. So I will go like this, then I will go down, I will go like this, and I will go down. This is the practical method in order to get the signs. If you want to rate this, although, also, if you want to do it as I moved from the left to the right, or from the right to the left, it's going to be the same for a 3 by 3. But the exact method, or the actual method, states that I will have, in order to get the sign of any of these cofactors, all I have to do is to put negative 1 to the power of I plus j. I'm sorry, I plus j, where I stands for the number of the row and j stands for the number of the column. So, for example, if I want to know the sign of the cofactor, which is 1, 2, first row, second column, first row, second column, it's going to be negative 1 to the power of 1 plus 2, which is going to be 3. So the result will be a negative sign. If I want to go for 2 by 2, 2 by 2, the result, the sign is positive. So all I have to do is to negative 1, get the addition of the row and column of this factor. So it will be an even number, so the result will be, the sign will be positive. I may use this rule if just I have a doubt in the sign, or I need to find the sign of a specific cofactor by itself, I will use this sign. Other than that, all I have to do, Ahmed, is to start from the first element, which is simply going to be even, because first row, first column, it's going to be 2. So I will start by positive, then I can go for columns, positive, negative, positive, then I will move negative, positive, negative, and so on. If you try to adjust it with the numbers, it's going to be okay. So this is called the sign rule of the determinants. I will use it with the cofactors if needed. Okay, I will get back once more to the evaluation of the value of the determinant using the cofactor method. First of all, choose any row, any column, the one that you like or you prefer. We usually use the first row. Feel more comfortable with the first row, but it's not true. You can use the first row, last row, first column, second column, third column, whatever. Okay, I will start with the first column. So I will get now the value of the determinant of A, which is very, very simple. All I have to do is to get for the first number, which is 3. I will write this element, which is 3. Then I will eliminate the row and the column that's connected by this number. So I will go for 3, eliminating the first row and the first column. Remark, what you will find here is a minor, okay, determinant, less than the degree of the main one by 1. So if I have 3 by 3, I will erase the row and the column, so I will have a 2 by 2. Start writing it. So it's going to be negative 1, 3, 5, and 6. Negative 1. Then I will have 3, 5, and 6. Next step, I will go for the second element. The second element sign, Ahmed, is negative. So I will put negative sign. Then I will take this number as it is, positive, positive, negative, negative, I don't care. So it's going to be 2. Once more, start eliminating the row and the column for the number 2. Okay, let me do it this way. This is number 2. Just eliminate the column and the row. The remaining elements, just write them down. So it's going to be 0, 4, then 3, and 6. Okay? In a similar manner, I will move to the next element. The next element will be positive 1. Positive because the sign. So it's going to be positive. Then the number which is 1. Once more, start eliminating the row and the columns that intersect at this number. So I will eliminate the first row and the third column. The remaining numbers are 0, 4, -1, and 5. And it will equal to. معايا سيف? I will start evaluate each one of these cofactors by itself. So I will start with the first one. So it's gonna be 3 times, start multiplying the elements of the principal diagonal. Salma, this is very, very simple. Don't lose it. -1 times 6, start multiplying the principal diagonal minus the secondary diagonal. So it's gonna be -1 times 6, which is -6. Then I will put minus from my mind. This is minus. Then 3 times 5, which is gonna be 15. Same way like سلمى. قولي لي التاني عامله ازاي؟ يبقى انا هحط الاول -2. بعدين 0 times 6, okay, which is gonna be 0. Okay? So the next number is gonna be 0. So 0 times 6. بعدين minus 3 times 4. So which is gonna be -12. In a similar manner, I will go for the last one. Okay, plus 1. Then I will also do it at once more. 0 times 5, معايا نور. بعدين minus -1 times 4. So I will have 0, خلي بالك يا سلمى, minus, then -4. So minus of a -4, it's going to come up to +4. Then get the sum of all of these numbers. So this is going to be -21 times 3. The other one is going to be +24. Remark for the sign conversions. 1 times 4 is going to be 4. Okay, يا نور اتفضل. ايه؟ عشان تجيب determinant for a 3 by 3. It's not that difficult because I'm just explained, but it's not that difficult. See, I will try it once more. The steps are okay? The steps are okay? Okay. بصي يا نور، أنا معايا ده. تعالي نحسبه سوا. أنت تقدري تعمليه, you can do it by your eyes. Okay. Let's start. I will do it with the first row. Okay, start. It's gonna be 10. Erase the row and the column. So the remaining numbers are 4, 6, 6, and 5. Then minus 7. Eliminate the row and the column. The remaining numbers are -3, 5, 6, and 5. بعدين plus the third number, which is
0.
And then erase the row and the column. So the remaining numbers are -3, 4, 5, and 6. This is exactly what's going to happen. Okay? So this should be the numbers that you will see. If you want me to write it down for you, I can write it. But I believe it's okay. Okay? There is another method to evaluate a 3 by 3 determinant. I will show it to you. This needs more concentration from you. Okay? I will erase this part and I will do it with you step by step. This is called Sarah's rule for evaluating a 3 by 3. Just before I start introducing this method, I want you to remember that if we try to evaluate a 3 by 3 determinant, we had to evaluate how many 2 by 2 determinants? 3 of them. Each one of them is less than the degree of the original 1 by 1. So I'm evaluating a 3 by 3, Ahmed. I have to evaluate 3 determinants 2 by 2. If I want to evaluate Noor, a determinant 4 by 4, can you tell me how many minors are we going to use? I have 4 of them. Each one of them, the dimension will be 3 by 3. So each one of the 3 by 3, you will have to, by using the cofactor, to break it down to be a 3 by 2. So simply, so if I have a 4 by 4 determinant, I will have to evaluate how many 2 by 2 determinants? 12 of them. This is a major thing for the determinants, which needs more attention for the rows and the columns that you are going to use in expanding this determinant. Okay? But for the time being, I want to introduce Sarah's rule. This is why I'm giving you Sarah's rule. تعال بص كده. Let's go through the numbers. It's 10, then 7, 0, بعدين -3. I will have 4, 6, then 5, 6, and 5. This is the matrix which is 3 by 3. Now I'm trying to get the value of this determinant of A using Sarah's rule. Sarah's rule states that دي محتاجة فهم. فأنت لو بصيت في الموبايل مش هتفهم الميثود دي. طيب أنا عايز أحسب الميثود دي، إزاي أحسبها؟ I will go أحمد for the principal diagonal. What's the principal diagonal? 10, 4, and 5. I will multiply all of them together. So I will say this is gonna equal to 10 times 4 times 5. So I've started with the principal diagonal. I will get the multiplication of the principal diagonal. Then plus, then Malak plus. Look to the principal diagonal. It's already separate this or divide this square determinant into an upper triangle and the lower triangle. Yes? Each triangle of these triangles has a base and a head. Okay? So I will multiply the base of the upper triangle by the vertex of the lower triangle. Look, 7 times 6, then times 5. 7 times 6, then times 5. Once more, do it. Do it, but from the lower base of the lower triangle in the upper vertex. So it's gonna be -3 times 6, then times 0. Once more. نور أنا عملت إيه؟
نعم.
عملت إيه؟ ها ضربت الاليمنتس اوف ذا برنسبل diagonal. اوكي؟ بعدين بلس عملت المالتيبليكيشن اوف ذا برنسبل diagonal which are 3 numbers. معايا سيف؟ يبقى 10 times 4 times 5. بعدين بلس I will take the upper base of the upper triangle times the vertex of the lower triangle. Okay? So it's gonna be 7 times 6 then times 5. Okay, ما هي الميثود كده. هتضرب 7 times 6 then times 5. بعدين بلس هتعملي العكس. هاخد اللور بيز اوف ذا لور triangle times 0 -3 times 6 times 0. Okay? Same way like but on the secondary diagonal. I will do it exactly the same but with the secondary diagonal. Boss, this is the secondary diagonal. Minus sign, open a bracket in order to avoid any mistakes in signs. Then start once more. معايا أحمد? I will do it 0 times 4 times 5. 0 times 4 times 5. Then plus. I will take the elements, okay, of the base of the lower triangle, which is 6 times 6 times 10. بعدين بلس عبد الرحمن كمل تقدر 7 times -3 times 5 يبقى إذا 7 times -3 then times 7 times -3 times 5 يبقى actually I will do it in 2 ways. I will take the elements of the principal diagonal then the 2 elements diagonally times the vertex of the lower triangle and vice versa. بعدين هعكسه اروح فور ذا ليفت سايد وهمشي نفس الستبس بالظبط تاني وانس مور. بصي يا سلمى انا بتخيل وجود تريانجل. بصي انا هعلم عليه وبعدين اشيله. بصي في هنا تريانجل شايفاه؟ باخد البيز اللي فوق بس في الراس اللي تحت والعكس. باخد البيز اللي تحت في الراس اللي فوق العكس. كده خلاص we are all set. يبقى I will do it how many times? 2 times. One of them with the principal diagonal minus the secondary diagonal. Why to go through all of this? In order to avoid to break the 3 by 3 into 3 2 by 2. So now I believe it's a little bit simpler that if you are trying to handle a 4 by 4 determinant. A 4 by 4 determinant, according to the cofactor method, there is no other way. I will have to go through the cofactor method. So I will have to break it into 4 smaller determinants, which is going to be 3 by 3. Each one of them I will solve it using substrate. This is exactly what happened here. Okay, the first elements 10 times 4 times 5 plus negative 3 times 6 times 0 plus 6 times 7 times 5 minus the other way. مالك معايا؟ سهلة قوي على فكرة، بس هي مجرد ان عينيك تاخد عليه. طبعا once you evaluate it, it's gonna be 155. Okay? Okay, perfect. Boss, this is this is the sign rule, and this is the case if I want to evaluate a 3 by 3 using cofactor method. If I go for the first row, so it's gonna be 10 times 4, 6, 6, and 5, which is gonna be simple like this. Then I will put the sign rule, which is minus 7, eliminate the row and the column, so the numbers will be negative 3, 5, 6, and 5. And for the last one, I don't have to evaluate it since it starts with 0. But just in case, because I want the slides to be in front of you, I hit 0, eliminate the row and the column. The remaining numbers are negative 3, 4, 5, and 6, and the result will be this. Okay? This is how to evaluate a value of a determinant. Okay? For a 2 by 2, for a 1 by 1, which is going to be the same number. For a 2 by 2, I will multiply the principal diagonal minus the elements of the secondary diagonal. For a 3 by 3, you have 2 ways. Either to use the cofactor rule, the cofactor method, which is, I don't recommend for a 3 by 3. I can go through Sar's rule. Of course, for a 4 by 4, you can't use Sar's rule on it. Sar's rule is working on a 3 by 3. There is another methods in order to evaluate a larger dimension than this. But people will go for the specific row operations in order to develop more number of zeros using the row operation of the matrices in order to make the work a little bit easier. But you will have to go through the series of the elementary row operations, but with the conditions in determinants, which is going to be different than the conditions in matrices. شباب في الماتريسيز انت بتستخدم الرو operations وتجيب an equivalent matrix, which is almost the same. But in determinants there is a difference in using the row operations in the properties of determinants. So it's handable, but it's not the same process. Okay, we will go through it shortly, inshallah. Okay, done. This is why we are taking determinants. I will go through the Cramer rule directly as it is the bottom line of why we use determinants in order to evaluate or to get the inverse using the determinant methods, the various determinant methods. Okay. تعالوا معايا كده. طبعا في بعض there is some properties, I will go through them shortly, the most famous ones of the determinant, which states that the value of a determinant of a matrix is exactly the same like the transpose the determinant of this matrix. So if I have this determinant value, it's going to be exactly the same if you change the rows into columns and vice versa. If you get the transpose of a matrix, they are going to be exactly the same. And if I wrote this values, you will find them by Saras almost the same. See, 10 times 4 times 5. It's going to be 10 times 4 times 5. Try to get for the upper, for the next step. So it's going to be 7 times 6 times 5. Remark, 7 times 6 times 5. And then you will go for negative 3 times 6 times 0. It's exactly the same. Negative 3 times 6 times 0. So they are exactly the same process.
Just for the 3 by 3?
No, for all of them. Getting the determinant for a matrix, it's exactly like getting the determinant for the transpose of this matrix. It's going to be the same. Okay, so this is one of the famous relations. If there is a complete row element, and this is really very important, If you have a complete row of elements are zeros, then the value of the determinant will be by logic equal to 0. Okay? It makes sense. Because if I have 0, 0, and 0, and if you try to go either by SARS or by the cofactor method, simply you will have 0 times a minor, minus a 0 times the second one, plus a 0 times the third one, so the result will be 0. Also, if you have two identical rows or columns, the value of the determinant will be equal to 0. So this is two major things you should keep in mind. If I have a determinant with two rows equal to each other, or two columns equal to each other, the result of this determinant will be 0. And also, if you have a complete row of zeros in a determinant, the value of this determinant will equal to 0. Okay, this is very nice property. I will stop here for the remaining properties of the determinants. I will go them shortly with a lot of details in the coming slides. But I want to introduce at the time being the Cramer method, which is really a very simple method to solve a system of equation. This was invented after the name of Gabriel Cramer, who lived between 1704 to 1752. He was a Greek, and it was through the 17th century. Mainly, Cramer solves the matrices with a unique solution. Other than that, it's not going to work. And you will discover the reasons by yourself. The steps of Cramer method are very, very simple compared to what you saw previously. All you have to do for a system of equation, let's say a 2 by 2 like this one, first of all, I will have to evaluate the following determinants. I will have to evaluate the coefficient matrix determinant. Then I will have an updated, let's say, A dash determinant, which stands for that I'm going to replace the column of the first unknown by the result column, as you will see shortly. And this is, I will call it delta of A relative to x1. And then I will evaluate another determinant, which stands for the elements of x2. You will see them there. All I have to do is to evaluate for a system of a 2 by 2, I will have to evaluate how many determinants? 3 determinants. So if I have 3 by 3, I will have to evaluate 4 determinants. If I have to solve a 5 by 5 system of equation using Cramer, how many determinants I should evaluate? 6 of them. So the number of determinants should exist, or at all times will exceed the number of equations by 1. This is the first step. The second step is really very simple. All you have to do to get the values of x1 is to get the value of the determinant of x1 divided by the coefficient matrix determinant. In a similar manner, for x2, you will have to get the determinant of x2 divided by the determinant of the coefficient matrix. You are all set. 2 steps. It's very simple. So if I have a 2 by 2 system of equations, all I have to do first is to evaluate the determinants for the coefficient matrix, for the first unknown, for the second unknown. Then all I have to do is to put the value of the determinant of x1 divided by the coefficient matrix determinant, and so on. This is why I told you this method is going to work only with a unique solution. Why? Because the coefficient matrix of a unique solution will not equal to 0. Any matrix with a determinant equal to 0, it's called a singular matrix. And for any singular matrix, first of all, it's not invertible. You can't get its inverse. This is number 1. And it's not going to develop a unique solution. So if I have a matrix, link these words with the system of equations that we talked in the previous lectures. If I have any coefficient matrix, now I can evaluate its determinant. If its determinant equal to 0, this is not going to develop a unique solution. If its determinant wasn't equal to 0, so that means the coefficient matrix is not singular, and then you will have a unique solution. Okay. Like, why Cramer is not dealing with the consistent system dependently? Because the consistent system dependent solution is the one who is giving you an infinite number of solutions. Why grammar is not working with it? Because if you have infinite number of solutions, you will find one of the rows of the main determinant equal to 0. And then the determinant value will equal to 0. And you can't divide by a 0 value. So this is why grammar is used only to solve or to analyze a 2 by 2 system of equation. This is the main method. Let's see how it works with the first set of equations. I will leave it in front of you. So if I want to use grammar method in order to solve this system of equations, all I have to do, first step, is to get the determinant of the coefficient matrix. Step number 1, I will get determinant of A, which is gonna be, how do you get a coefficient matrix? 3, 1, 1, and 2. Yes. 3, 1, 1, and 2. And on the same setting, I will evaluate, I will get the value of the determinant, let's write it here, the value of the determinant of x1, which is simply going to be exactly the same determinant, but I will change the column of x1 by the results. So I will go changing x1. This second column will be the same, so it's 1 and 2. The first column will be 5 and 4. Exactly in a similar manner. I will go to get the determinant of x2. This is A, and that's x2. The determinant of x2 will be, I will change just only the column of the elements of x2. So the first column will be the same, 3 and 1. For the second one, I will replace it with 5 and 4, which is really also handleable and really very simple. All I have to do is to evaluate each one of these determinants. Ahmed, the first will be 3 times 2, which is going to be 6, minus 1 times 1, which will develop 5. The second one, which is also handleable, 5 times 2, minus 1 times 4, which is going to be 10 minus 4, the result will be. The last one, which is also will be very simple, 3 times 4, which is going to be, okay, minus 5. And the result will be 12 minus 5, so it's going to come up to a 7. The result is very neat. All I have to do is to evaluate now the value of x1 and the value of x2. So the value of x1 simply, this is the value of x1, will equal to the determinant of x1 divided by the coefficient matrix determinant. So all I have to do is to just simply get 6 over 5. The value of x2 is going to be really also very simple. All I have to do, getting the value of A, but with this is x1, that's x2, divided by A, which is going to be 7 over 5. You are all set. Done. This is the solution of a system of 2 by 2 equations. Remember, if I have to solve this system with Gauss elimination, you will have to form the augmented matrix, which is going to be 3, 1, 1, 2, then a dotted line, 5 and 4. I will have to use the row operation, the equivalent row operations that we did previously, in order to reach it to reduced echelon 4. So I will have same results exactly like this one. It's really very simple and recommended if you are trying to solve a system 2 by 2. Okay? What if this value equal to 0? You are not going to be able to use Cramer's method, because simply the matrix A is a singular matrix, and hence this system will never have a unique solution. It will have infinite number of solutions, because if you try to go through row operations, you will find one of these rows equal to 0. Okay? Once more, بص انا ممكن اكتبه بسهوله قوي. Once more, اول حركه هروح اجيب الديترمنت بتاع الايه 3 1 1 and 2 which is simply I can evaluate it with my eyes. 6 minus 1, so it's going to be a 5. Keep it in the back of your mind. Second step, I will replace the first row, the first column, by the results, which is going to be 5 4 1 and 2. So simply 5 times 2 10 minus 4 6. The first variable value, it's going to be 6 over 5 using your mind. The second one also is really, very simple. All I have to do is to replace 1 and 2 by 5 and 4. So it's going to be 12 minus 5, which is 7 divided by 5. You are set. Same way like this is x1 and that's for x2. What if I need to use, or I would like to use Cramer method in order to solve this system of equations? Bardo, it's going to be exactly the same way. But in this case, how many determinants I should evaluate? 4 of them. The first is the coefficient matrix. معايا عبد الرحمن? The second one, I will replace the x1 column by 7, 4, and 6. The second one, I will replace x2 column by 7, 4, and 6. The third one will be replacing the third column by 7, 4, and 6. على فكرة أنا ممكن أكتبه على طول دايركت في الصورة بتاعت الريزلتس. أهي. سي بس خلي بالك دايما وانت بتكتب سيستم اوف ايكويشنز ان يكون واحد من الفاريبلز متلخبط. يعني بص كده انا ممكن اعمل ايه؟ دايركت. بص x 1 will equal to give me the determinant of the coefficient matrix. قول كده يا سيف.
10
ها
negative 3 5.
هتمشي رو ولا كولم؟
لا كولم.
طيب 10
negative 3
روعة. بعدين
5.
بعدين 5. طيب 4x2
negative 7
اوكي بيرفكت. نيجاتيف 7 ها 2 بعدين negative 1. 4x3 is gonna be
0
yes. Then
6 5.
بعدين 6 and 5. This is the coefficient matrix determinant. If this matrix